Hello, this video is going to introduce you the forecast package in R. And in this video, we are going to be working on moving average method, how we are going to be making forecast with moving average method in R specifically. So as I said, we are going to be working on this forecast package. So I already installed it on my computer. If this is the first time you are actually using forecast package, go ahead and run this line of command in line 3. So it is going to be installing the forecast package on your computer. And after you're done, you will just need to comment it out because you are not going to be reinstalling this line at all. So once you install it once, you will keep importing it like this so that you could get to run forecast package functions. Okay, so pause this video, install this forecasting package, and then come back. We are going to be moving forward with the moving average forecasting methods in R. All right, so if you install it successfully, all you have to do is to come over here. You don't have to select the entire line at all. Your cursor has to be on that line, and you're going to execute this line to load forecast package. So we are basically telling R that we would like to use forecast functions. And the first one that we are going to be using is MA. MA stands for moving average method, okay? So you could call the help menu like this to see like how it can be put in action. But it's going to be very simple. First, we will have to import the data set that we will be working on. And it is the burglaries data we worked on in Excel. We already have the burglaries Excel file. It comes with your Canvas course package. So make sure that you downloaded forecasting.r file, which is going to be this entire set of codes that you will see in it, and the burglaries Excel file and Guess Electric Excel file. Okay, so I'll be working on burglaries for now. I will be importing it, make sure that the name appears as it is shown here on the screen, and import. So our burglaries data set looks like this. We do have monthly burglaries, right? We do have the month number here, and then the burglaries numbers on the second column. Okay. So MA itself is just a function, right? So as you just type MA and then open the parentheses, in parentheses, you will have to enter um, three important parameters actually. The first is going to be the burglaries in the burglaries data set, right? That's how we call a specific column in the data. So we are going to be making a moving average forecast on this column. And the order is here is basically the K that we used in the Excel video that I just posted and then you just watched, hopefully. That will be the identical phrase. Order is going to be used interchangeably as K. We are going to be asking this method to look for the previous most current 2 time periods, take the average, and then represent it as your forecast. Center being false here is going to direct this moving average method not to look 1 period ahead and 1 period before, just directly look for 2 time periods before the current time period and use it as the average, use the average of these two as your forecast, okay? So we usually put center false here, and if you would like to learn more about it, you can come over this help menu and then learn more what center means. So this function is going to return you a moving average forecast object, and then I named it as MA2. So you can name this anything you want, but I wanted to name it MA2. And then let's execute this line. You'll see that MA2 appears as a time series model here on the top right. And let's see what it entails in this line 13 to see what it looks like. As you can see, it looks like this. It gives you the forecast that this method just made by using moving average method with k is equal to 2. How do we make a forecast with it? Well, we can use forecast function directly, and I'm going to be storing it as FMA2 in this file, and it's going to appear here. How do you forecast with a forecasting object? Well, first you have to have it as an object, and then you need to call this here in the first parameter in the parentheses of forecast method. And H here is a specific parameter. It's going to tell you how far ahead you want your forecast to be seen. I specified 10. So it's going to be making a forecast for the 10 next months. All right, see how it looks like. So let's execute this. Gives me a warning message, it's not an error message. So let's also call this forecast method to see what it looks like. It looks really cool because it gives me the point forecast. It is actually the last forecast that it made based on the current data points by using two most current data points, right? It basically took the average of the two most current burglaries number and then using it as a point forecast. As you know, it is going to be fixed with moving average. It's not changing. The same with exponential smoothing, but other methods are going to be changing this point forecast. But it also gives us the lower 80% and higher 80% confidence level, a lower 95% and higher 95% confidence level as well. Well, how did we do in terms of accuracy error metrics? Well, let's call accuracy function. And then you see that these are all error metrics. And I tend to look at MAPE mostly. It is mean absolute percentage error, and it gives me 14% error. It's going to be very useful because I'm going to create some other moving average forecast and I can compare their error metrics to decide which one is giving me less error. And this is on the training data, meaning that this is going to be looking at whatever data that I have. And let's see if we plot this forecast, let's see what we will get. It's just simply plot in parentheses the forecast object that you just typed in. If you plot it, it looks cool because it gives me this with this black line, my data set, burglaries data set, and into the future, right? So this horizontal blue line is the point forecast. The first blue shaded region is actually my 80% confidence interval. And also the outer shaded region is basically 95% confidence interval on my forecast. All right, so let's see if we change this order parameter from 2 to 3. In the assignment, you're going to be doing this. You are going to be working on multiple different K values. And this is how you can actually very easily create forecast methods in R. And let's do, I'm not going to change anything. All I did is I copied this entire code and then pasted here, change the name of this forecast to MA3, because I'm going to be looking at 3 most current observations and taking the average of it and making it a forecast. So let's run everything here. This is my MA3 object, and it looks like a time series. And then let's make a forecast by using this object for the next 10 months. And these are my forecasted parameters. Let's take a look at the accuracy. Well, you see that MAPE, it was 14% by using K equals to 2. It got down to 10.9. It looks like it is getting better when I increase the order value from 2 to 3. And let's plot this forecast. And this is the forecast that you would get by using K is equal to 3. This is the forecast when you get with K equals to 3. All right, so can we increase it to 4? Yes, we can. All we have to do is to change just one parameter. And let's keep running these lines. I'm going to be looking at the accuracy. Accuracy went even further down to 8.9. So it is actually getting better. And these are all other error metrics, different error metrics and different definitions. You don't need to know them all. You can stick to one or another. But MAPE is a commonly used one in the industry. Okay, let's take a look at the plot itself. You can compare their plots here on the right. You can copy them, paste them anywhere you want. You can look at the accuracy measures as well. So in the assignment, you are going to be copying these plots and also copying these accuracy numbers, and you are going to be asked to compare them over certain forecast parameters to decide which one is better. Okay. Okay, on the next video, I'm going to be talking more about how we can do simple exponential smoothing forecasting models in R.